Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this lesson, please take a moment, hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 7 on quadratic equations, Lesson 18. This is Part 2 of applying the quadratic formula. The learning goal for this lesson says let's use the quadratic formula and solve quadratic equations with care. Meaning, we want to pay real close attention to how we solve it because it's very easy to put in the wrong number, put in a negative when it should be a positive, leave out the negative when it should be there, or make simple little mathematical errors. There are 2 learning targets in this lesson. When we're done with the practice problems, we'll come back and review these to make sure you've learned everything you needed to before moving on to the next lesson. Learning target number 1 says that you can identify common errors when using the quadratic formula. So things like the wrong sign, having it plus when it should be minus, having it minus when it should be plus, not paying real close attention when you're putting the numbers in and putting the wrong value in for the wrong variable, or making simple mathematical mistakes when you're doing the adding, subtracting, multiplying, and dividing. Because we start to look at the big picture because of it being this complicated looking formula, and we get so focused on that we forget to take the time to look at the small, more simplistic mathematical steps that are involved. And learning target number 2 says that you know some ways to tell if a number is a solution to a quadratic equation. The glossary term again is quadratic formula itself. You can see the formula here. X equals negative b plus or minus the square root of b squared plus 4ac, all of that divided by 2a. Remember that it needs to be in standard form, set equal to 0. Then you identify a as the coefficient with x squared, b as the coefficient with x, and c as the constant. You'll plug those values in, complete the math, and solve for x. Now we can begin the practice problems for Algebra 1, Unit 7, Lesson 18. Mai and Jada are solving the equation 2x squared minus 7x equals 15 using the quadratic formula, but found different solutions. We can see Mai's work on the left, and we can see Jada's work on the right. Number 1, if this equation is written in standard form, set equal to 0, what are the values of a, b, and c? In order to set it equal to 0, we would need to move this 15 to the left side. The opposite of positive 15 is negative 15. So we're going to subtract 15 from both sides. Now when we write it, we would have 2x squared minus 7x minus 15 equals 0. That means the value of a is 2 because it's the coefficient in front of the x squared. The value of b is negative 7 because it's the coefficient in front of x. And the value of c is negative 15 because it's the constant. Number 2. Do we agree with either of them? Explain our reasoning. So let's see how we would do it. The formula is x equals negative b, which is negative 7, plus or minus the square root of b, which is negative 7 squared, minus 4 times a, which is 2, times c, which is negative 15. And all of this is over 2 times a, which is 2. Now, I already see a problem with Mai's work. When Mai was filling this out originally, she put minus 7. But that should have been negative 7. So this is where Mai made a mistake. And now every step after it is going to be wrong because she continues to have this negative 7 when it should become a positive 7. So we know that Mai is wrong, and that's why. Now we can continue. As we just said, negative 7 is going to become positive 7, plus or minus the square root. We have negative 7 squared, which is 49. Then we have negative 4 times negative 15, which is going to be positive 60, times 2, which is going to be positive 120. So plus 120. And all of this over 2 times 2, which is 4. And now I can see where Jada made a mistake. When Jada did the square root of negative 7, she actually did negative the square root of positive 7. So when she did that, she got negative 49 where she should have gotten positive 49. Now that's going to make everything wrong after that. So they're both wrong. Let's go ahead and keep working. This becomes 7 plus or minus the square root. 49 plus 120 is 100 69, all of that over 4. The square root of 169 is plus or minus 13. Now we can find the true answers. The first answer is that x equals 7 plus 13 divided by 4, which becomes 20 divided by 4. So the answer is 5. Notice that in my solution, she got negative 5 instead of positive 5. Now, the other solution is 7 minus 13 divided by 4. 7 minus 13 is going to be negative 6. And we can simplify this to negative 3/2. Again, notice that my got positive 3/2 instead of getting the negative 3/2. And that all goes back to making the mistake in the very beginning when this should have been positive 7 instead of negative 7. Jada's mistake of taking the square root of 7 and making it negative instead of taking the square root of negative 7 made it so that she ended up with an irrational number, so she never got close to the two actual answers. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 says the equation here represents the height in feet of a potato t seconds after it was launched from a mechanical device. Number 1 simply wants us to write an equation that would allow us to find the time that the potato hits the ground. So here's what they mean. If a potato is on the ground, then the height must be 0. The equation itself, h of t, is representing the height of the potato above the ground. That means they just want us to set this standard form equation equal to 0. So for number 1, we're going to have negative 16 t squared plus 80t plus 64 equals 0. Now, number 2 wants us to actually go ahead and solve this. And they want us to do it without graphing. So we're going to use the quadratic formula. We need to identify A, B, and C. A is the coefficient in front of t squared, so that's negative 16. B is the coefficient in front of t, so that's 80. And C is the constant, so that is 64. Now we can fill in the quadratic equation, or quadratic formula. This will be t equals negative b, which is 80, plus or minus the square root of b, which is 80, squared, minus 4 times A, which is negative 16, times C, which is 64. And all of this is divided by 2 times A, which is negative 16. So we've got negative 80 plus or minus the square root. 80 times 80 is going to be 6,400. Next, we have negative 4 times negative 16 times 64, which is 4,096. And all of this is divided by 2 times negative 16, which is negative 32. So now we have the square root of 6,400 plus 4,096. That's going to be 10,496. So if we put this into a calculator, 10,496, the square root, notice this is going to be an irrational number. So we could leave it like this, but this does not make a lot of sense right now. This would be very hard to piece together an answer in relation to time. So what we're going to do is we're going to go ahead and solve this with it written this way. So I'm going to say that it's negative 80 plus the square root of 10,496 divided by negative 32. And I'm going to put that in the calculator. So I just took the square root of 10,496. Now I'm going to add this to negative 80. And now once I've got the top, I'm going to divide this by negative 32. And that gives me negative 0.7. Then I'm going to solve it by saying that I have a minus square root of 10,496 divided by negative 32. And we'll put this in the calculator. So again, 10,496. We take the square root. Now we make this negative. Then we subtract 80. and we get the minus 182 and the rest of it. Now we're going to divide it by negative 32. And this is going to give us 5.7. So the negative one would say that the potato hits the ground before it's launched. And this doesn't make sense. However, the other answer means the potato hits ground approximately 5.7 seconds after it's launched. This answer makes sense. So that is the answer that we would use. If you have any questions about how to solve this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3 is the last practice problem in this lesson. Priya found x equals 3 and x equals negative 1 as solutions to this standard form equation set equal to 0. Is she correct? And show how you know. So there are 3 different ways that you could answer this question. Number 1, put the equation in a graphing calculator and verify the x-intercepts are at 3, 0 and negative 1, 0. That is the quickest and easiest way. So if you have a graphing calculator available, you can do that. The second possible way, substitute three and negative 1 into the equation for x and verify they both make the equation true. This is the second possible way that you could answer this question. But since this lesson is about using the quadratic formula, Let's do that. So if we have 3x squared minus 6x minus 9 equals 0, then a equals 3 because it's the coefficient in front of x squared. B equals negative 6 because it's the coefficient in front of x. And C equals negative 9 because it's the constant. Now we can plug these into the quadratic formula. X equals negative b, which is negative 6, plus or minus the square root of b, which is negative 6, squared, minus 4 times a, which is 3, times c, which is negative 9. And all of this is divided by 2 times a, which is 3. Now negative 6 becomes positive 6. Negative 6 squared is 36. Negative 4 times 3 times negative 9 equals 108. And 2 times 3 is 6. "36 plus 108 is 144. The square root of 144 is plus or minus 12. At this point, I know that 6, 12, and 6 are all divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. And 6 divided by 6 is 1. So we can just leave this as our answer. So the first answer is that 1 plus 2 equals 3. And that matches the first answer at the top. The second answer is x equals 1 minus 2, which equals negative 1, and that matches the second answer that Priya found at the top. So again, all 3 of these methods are valid. All 3 of them will work. They will all find the same answers for you. I just chose to do it the third way simply because this lesson is about solving by using the quadratic formula. If you have any questions about any of the practice problems, please leave a comment below and I'll get back to you with any help that I can offer. Now, before we finish this lesson, let's go back and review the learning targets and make sure you understand everything you need to before moving on to the next lesson. To finish up, let's review the learning targets for this lesson. Number 1 says that you can identify common errors when using the quadratic formula. As we saw in the practice problems, the most common errors are substituting in the wrong numbers, forgetting about your signs, making a positive a negative or a negative a positive, or just messing up on the more simple mathematical processes such as the adding and subtracting, the multiplying and dividing, the squaring of numbers. So even though you're paying attention to this big overall complicated looking formula, make sure you slow down, take your time, check that you're putting in the right numbers, check that you have the right symbols, and always double check yourself. Always take your answers, plug them back in, and see if they make the equation true or not. Learning target number 2 says you know some ways to tell if a number is a solution to a quadratic equation. And this kind of goes back to that last one. One way is if you have access to a graphing calculator, type the equation into the graphing calculator. It will draw the parabola for you, and then you can verify that the answers you got are the x-intercepts on the graph that the graphing calculator draws. Another way is to simply take those answers and substitute them back in for x and see if it makes the equation true. And then you can always work the problem out and make sure that the answers that you got are the same ones that you're supposed to verify are true. So there's a lot of different ways to do it. Make sure you're picking the method that you have the ability to do, that you are comfortable doing, and that makes sense to you and you have confidence in doing. If you have any questions about anything on this lesson, please feel free to leave a comment below and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see a video that YouTube believes you will find helpful. In the bottom right of the screen, you should see a subscription button for the channel. If you find this material helpful, please subscribe to the channel, give this video a thumbs up, and I look forward to seeing you in the next lesson.